Welcome back, everybody. Welcome to another training session with Aeromotive. Today we want to talk about contact resistance. What is contact resistance? That is the resistance between the two mating surfaces of the terminal. That mating surface is very small. It does not cover the complete terminal. So what happens is, over a period of time, oxidation forms, or in many cases, our own troubleshooting techniques create problems. Let me give you an example of how that happens. So you're out in the vehicle and you want a test probe. So you take out your ohm meter. Right? You take your ohm meter and you force it into the terminal. Well, you just stretched the terminal and elongated it. It doesn't have the same amount of pressure it would have, thus increasing your contact resistance, or in industry terms, constriction resistance. Constriction, that's the mating surfaces of the two terminals. The current flow is constricted by the surface area of the mating ends of your terminals. So in this case, you just stretched it and increased your constriction resistance. Other ideas have been paper clips. People have pushed paper clips into terminal leads. That also elongates the terminal and also increases your constriction resistance. So what do you want to do? Well, create yourself a jumper lead that has the mating terminal on the other end. By doing so, you can reduce the stretch or elongation of your terminal. Another thing out on the marketplace are these pins with alligator clips on them. Obviously, you can see it doesn't elongate the terminal as much and allows you to easily get into the female side of that terminal. Gives you a clip on the other side so you can get a lead on that. So, say, big deal, I stretch the terminal a little bit. But how does that affect my constriction resistance? Well, let's look at an example. Say you take these two leads and you elongate this mating surface by 10%. Let's look at that at wire gauge. This is your constriction resistance of this mating end of these wires. This is, obviously we blew this up to give you perspective. But if you increase the constriction resistance on this mating surface by 10%, you've now reduced that wire gauge to this. Try to get that much current to flow through this type of wire. Thus you get a constriction resistance. Your resistance increases, and what does that lead to? Overheating terminals and possibly shorts, meltdown of the connector housing, electrical overloads, etc. So, in a nutshell, when you go to test probe, make sure that you're aware of what you're using to insert into your terminal ends and reduce that constriction resistance. Thanks for tuning in.